Number 5, a man buys a house for $350,000. He makes a $150,000 down payment and amortizes the rest of the debt with monthly payments over the next 30 years. And if you've been paying attention to my advice, this is a bad idea. You should try to do it in 15. The interest rate on the loan is 6% compounded monthly. What will be the size of his monthly payments? How much will he pay in total for the home? And how much of this is in interest? And so we need to recognize, first of all, that he is not borrowing $350,000. He's borrowing $200,000 because he made a $150,000 down payment. So our amount borrowed here is going to be 200 grand. The payment, we don't know. The rate that he's getting this at is 6%, paid monthly, and over 30 years. So R over M is 0.06 over 12. I remember from a previous problem, I think that's going to be 0.005. And then MT is going to be 12 times 30, which is 360. I'm just going to verify on my calculator really quick that that really is 0.005. And it is. Okay. So we have an amount being borrowed of 200 grand. Don't know the monthly payment. 1 minus 1 plus I, and I should put my 0.005 there. 0.005 to the negative 360. 12 times 30, yep, okay. Over 0.005. So we hit the Wolfram. And we are borrowing 200,000. Another monthly payment, I is 0.005. N is 360. And again, the I is 0.005. So we got to divide by 166,792. And his monthly payment is going to be nearly $1,200. And so monthly payment is $1,199. $10. A little bit of a weird rounding on this problem. So monthly payment, so A, monthly payment is $1,199.10. So we are always asking ourselves, in terms of loans, how much is this going to really cost me? What's the total payoff amount? And how much is going to be paid in interest? And so that's the questions for part B. So total payoff is the amount. So 1,199.10 times 12 months in a year times 30 years. I think this is going to be ugly. So in my calculator here on the side, I've got 1199.10 times 12 times 30. Ooh, man, this guy is going to owe big time. So total payoff is 431,676. So total payoff is $431,676. Interest paid is whatever he borrowed, whatever he total payoff is minus what he borrowed. So he borrowed 200,000. Our total payoff is 431. So he's paying $231,676 in interest. Holy moly! The dude is literally paying for his house more than twice with this loan option. I feel for the guy. He's paying for it twice and some more, actually. Doesn't seem like such a great deal anymore, does it? So let's continue some more options for this person with part C. What impact would taking a 15-year loan at 4.25 interest instead have on parts A and B, and what should he do? And so let's take a look. We're going to have to do our new CERMTN down here. So CERMTN, let's see what we got. We're still borrowing 200 grand. It's going to go, we're still looking for what the monthly payment's going to be. The rate is going to drop to 4.25%, and I'll say this again, the shorter term a loan is, usually the lower the interest rate. Still going to be paid monthly. This time it's going to be done in 15 years, not 30. Our R over M is going to be 0.0425 over 12. And our MT is going to be 12 times 15. So in this case, 180. So let's see if that I divides evenly. I don't think it's going to. 0.0425 divided by 12. Nope, it doesn't. So I got to leave that as a fraction. So what we got is S equals R times 1 minus 1 plus I to the negative n over I. So 200,000 equals, we don't know what the monthly payment's going to be. 1 minus 1 plus 0.0425 over 12 to the negative 180 over 0.0425 over 12. Boy, it's kind of a nasty one. Alrighty, so in our Wolfram we got there. Still borrowing 200,000 bucks. And I still can't get over the dude had to pay, would have to pay for his house more than twice with the other option. So hopefully this one is a better option. It's crazy how many people get suckered into it. So, because, oh, you can afford the monthly payment. Yay. And in the meantime, they're making you poor and they're making themselves rich with your money. So, isn't that a great feeling? Anyway, let's figure out what the monthly payment's going to be. We got to go ahead and divide like we do. 132.93. So 132.93. We end up with a monthly payment of 1,504.55. So R equals 1,504.55. So I think this is C. So yep, C. The new monthly payment would be $1,504.55. That's not a huge jump. It's from about $1,200 to about $1,500, so about $300 more a month. Frankly, you could probably make about $300 a month driving for Uber or doing Instacart or something like that. So let's see what sort of impact this is going to have for this person. So total payoff is 1,504.55 times 12 times 15. And again, this 15-year loan, I'm just predicting, is going to kick the crap out of the 30-year loan in terms of how much this dude is going to actually pay to get his house paid off. So times 12 times 15. On my calculator on the side, total payoff is $270,819. Let's compare that to the 30-year loan. 278.19 compared to 431. So there is about $160,000 difference between these two. So he would save $160,000 if he's able to afford the 15-year loan. And I'm just going to tell you right now, okay, I would find a way to get that $300 a month. I would drive for Uber Eats. I don't care. I would get that done because he will have the house paid off in 15 years. That's 15 years less of house payments. He'll save himself somewhere in the neighborhood of $160,000 bucks. Why would you not do that? I would do whatever it takes. That's just me. So let's see what the other questions were. How much would you pay for the? How much overall would you pay, and how much of this is in interest? And so the amount in interest. So interest paid is he borrowed 200,000. He's only paying $70,000 in interest. $70,819 in interest compared to $231,000 in interest with this option. And so, again, you can see just a gigantic difference in the amount of interest paid. Uh, my advice, and so for Part D, we're asked to advise this person. My advice would be to do whatever it takes to get the 15-year loan. Okay, and this saves the buyer. I'm running out of room here. Buyer about 160,000 bucks, and 15 years of payments. So for after 15 years, this person has another, what's the monthly payment? $1,500 in their pocket that they don't have to spend on a house loan. Whereas if they go the other way, for another 15 years, they're going to keep having to pay $1,200 a month. Again, everyone, for me, it's just a straight up no brainer.